HTTP. Where do we see HTTP? Where have you seen it in real life? Any web page you go to always starts with HTTP or HTTPS. HTTP is another acronym, yay. And it stands for Hypertext Transfer Protocol. I'm going to put with an S there. So hypertext, what is hypertext? What does HTML stand for? Close. What does HTML stand for? Hypertext Markup Language. So HTTP is the set of protocols for how do we transfer our markup or our data across the web. So traditionally, you would transfer HTML files. So it was the way to transfer HTML files for a new web page. Now we can transfer JSON. We don't have to do that. It's still out there, but JSON is becoming the preferred option for anyone using a framework. All right, so hypertext transfer, that's the first bit of the acronym. How do we transfer stuff? And what do we think of when we hear the word protocols? What's another word for that? What is that? Procedures, rules. Yeah, so this is simply put, the rules that govern how data is passed around or passed between web servers and web browsers. So I am on a web browser, I am the client. I want to see what Google's site looks like, so I say take me to www.google.com and I hit enter. That is actually sending a request to a server through HTTP. That's why the website starts with that, showing us we are following the standard web rules. And I'm asking them to go get me their homepage. They get my request and they send it back. And it happens in a split second, but really this it's quite amazing what just happened when you just press enter. Goes and gets the web page. So the rules that govern how data is passed between web servers and web browsers. The nice thing is, because we have this set of rules, this set of protocols, this is worldwide. This is why you can load up a website that was created in India or China, well, probably not China, somewhere that allows public websites. You can send a request and they know what you're asking for because they are following the same rules, regardless of language or country or what have you. This is the main piece. Yeah, and that's it. No. So we have HTTP, hypertext transfer. What it is, protocols. So if you're asked what are protocols, they are rules or procedure, things that we follow in a specific way for a specific result. But let's cover a couple few pieces of terminology we may have heard, but don't know exactly what they are. So IP address with 2 Ds, yeah. IP address. Does anyone know what IP stands for in IP address? Good idea. Internet Protocol Address. Now, what is the protocol that governs the internet? HTTP. So everyone that's following HTTP needs an address, because when I send a request to Google by saying, hey, I need your homepage, how do they know who to send it back to? There's millions of people asking for this homepage every day. Along with my request, I'm sending my IP address, my address of where does this request originate from. So once you have the response, who do you send it back to? So your device's unique identifier for the web. And every device has their own IP address, right? Computers, laptops, phones, they're all their own individual. It'd be weird to make a request on your phone and Google pops up on your laptop. Doesn't work that way. If you see an IP address, they follow this pattern. There are 4 numbers separated by periods between the ranges of 0 to 55. This is not important, but this would be an example of an IP address. Any of these could be between 0 and 255. That's just an example. how they're situated. We'll never actually deal with them, just know they're there, and that's how this is communicating with you specifically. It knows your number. Okay, so what happens? What happens when I actually type in an address like www.amazon.com? What happens when I hit enter? Let's learn the journey. Through illustration. Yay. No, I realized we finally got a cable for this because I know the whiteboard isn't best for everyone. This hopefully is a little easier to see, regardless of where you're sitting. Is this on your screen right now if you're joining the call? Yeah. Perfect. Okay. So all requests originate from a client. So let's make a little client here. I've got my fancy computer. Here's my client. This is anyone using, trying to access a website. I try to go to google.com and I hit enter. This springs into action an event. I am the client and I am making a request. To what? Where does my request first land? A server. And if you've watched any hacker type shows, they look like big boxes with no screens, very intimidating. How do we talk to them? We don't know. But we have a server. The server is saying, thanks, I got your request. You're requesting google.com. Let me go get that information for you. So it does do something over here we'll look at later. It goes and gets the information. And then once it has the website for us, it sends back something. And this has to be a nice line or else it'll go crazy. One more time. Yes. So if this is the request, what do we think the server sends back? A response. Sweet. So we say, hey, I would like google.com. And it says, great. Here is the HTML, CSS, and JS. So that's how it used to be. What is sent now instead most of the time? JSON. Now, Google probably still sends XML, to be honest, but most of the time, what we'll be using, this will send JSON back as a response. So give me the data for this website, it will send it back and compile it. What did I do? Stop. X. Okay. This right here, this process is known as the request response cycle. Because this happens every time you click something on a site. You're making another request to a server most of the time, and it has to send back a response in a split second so the user doesn't see this loading spinner while the server is trying to find the data we're looking for. So far, we have done everything right here. Today, we're going to reach out and ask for information from somewhere on the internet. Very brief overview. We're going to revisit this in about 4 weeks. What is this little intermediary step? But it is good to know at this point, the server doesn't really care what we're requesting because the server doesn't hold the data for the website. The server is the courier for our request. So once the server receives it, it passes it off to an API, and that API queries a database. So the server says, hey, I got this request, API, go get the data. The API comes back, says, hey, I got the data. And the server's like, great, I got the data, and sends it back to the client. We're going to spend the next week and a half on this process here. How do we talk to a server? Because we don't care how the server is talking to the database. That's not our problem. We didn't build the server. We're just going to ask the server for data. It's going to do this little magic bit and then send us back the response. Once we get through React, we will then jump into this section and spend 2 weeks learning that interaction so we can make full stack applications. But let's get this So any questions or observations on this that came up? It's the first time most of you have seen like what actually is happening, at least high level? No? Anything servers? Servers can be two different things. Let me change the color so we can maybe, there are two types of servers that we'll be working with. There are local and there are remote. So what is a local server? You're using one already, by the way. Even more local than that. It's your own computer. If you're running a server on your computer, it is a local server. So when you're in VS Code and you say open in live server, that's booting up a live server locally to serve up your local website. Why do we know it's local? Can anyone else visit your website when you're developing it on a local server? No, it's private to you. So the alternative or the other that we'll have is remote. So what, if local is your computer, what is remote? Not your computer, right? Yes. Anything that's hosting a server that's not on your computer is a remote server. And this is the majority of ones we'll deal with. You're only really dealing with local servers when you're developing, because eventually you need to put it up on the web remotely so anyone can access it. So we got local, which is your machine. And then remote. It could be in the room next door, it could be on the other side of the world, doesn't matter. It's remote. Cool. Okay. And that's it. That's how data is passed around. The only thing we have to fill in now is all the code that does this, which is the hard part. Which is new. So, that aside, I would like to share an analogy. Again, here is another example of the request response cycle, like a little infographic. Client makes an HTTP request, they get back an HTTP response. The server follows the same rule as the client. And yeah, I'll put this in Slack. It's a good, this is a really short read, but it gives you a nice overview of what's happening. So let's talk about what are the main HTTP rules and protocols we're going to live by. And the way that we orient this is with a fun little acronym, CRUD. C-R-U-D. The C, actually let me do this in the notes so we don't have to dim stuff out. CRUD. The C stands for create. The R stands for read. The U stands for update, and the D stands for destroy, which is the same thing as saying delete. Destroy. Destroy. So these are the four main rules we're going to live by, the four protocols that we get to do. And when you visit a website and hit enter, you're making one of these requests. So let's put these into their HTTP terms. So create is a post, read is a get, update is a put, and a delete, fortunately enough, is delete. And it's with these four operations that pretty much any website you visit is able to do what they do. So if you had to guess, and I know I'm just asking you to guess here, but when I request Google's website, which one of these four requests am I probably making? Get. I would like to get some stuff. Thank you. So yes, I make a read request, or what it's really called is a get request. I would like to get some information, please. So when you type in your website and you press enter, like so, Google.com, sent an HTTP GET request to Google server. So they could send me back an HTTP response. So get is getting data website. Or I'll just say getting data. Post. What is a post? So post is, let's say we have a database. You're the first person visiting Instagram. Yeah, you're not a user on Instagram yet. You need to be created into their website. So later on, you can come back and log in. They know who you are. Well, a post request is what creates an entry in a database. So you don't exist yet as a user, but then you submit your username and password and hit enter. It sends a post request with your data to the server so it can save it in the database and remember you. So this is to add new data to a database. Who wants to guess what delete does? It deletes something from a database. So we have the ability to get data, add data, delete data, but what's a fourth operation we need to be able to do? Yeah, my last name changed. I need to go log into my account and change that, or my address changed. I shouldn't have to delete my old object in the database and create a new one. Let's just update the one that's already there so I don't have to do all the extra work. So a put is a update an existing database item or object. What other interactions outside of these four can you really think of that we'd need on a website? Have the ability to get data, add, remove, and update. So we're going to focus on these four for the rest of the course. You'll be putting these in your apps. However, for the next week or two, we'll mostly just be doing GET requests in real live code, but we're going to do an overview right now of all four of these and actually practice it ourselves. And to do so, we all get to install a new program. So if you would go with me, open up Chrome, and we're going to go to, I think it's get, let's see, let me figure it out before I send it to you, their exact website, the getpostman.com. Yes, getpostman.com. It looks like this, getpostman.com. Hope he's okay. And then once you're here, we got to find their button on where to download it. So maybe we'll click Get Started and then Download. Perfect. And let's all download and install Postman. This will take maybe 5 minutes for all of us to get through. It should download pretty quick. I'll open the zip. It might just take a minute to install. Great. Got the Postman coming along. And it'll show this little Rocket Man icon on your toolbar. You're going to want to keep that down there because we're going to be using it all the time. And once you get it open, we'll continue with using it. While it's installing, let's talk about it. Come on, Postman. Okay, there it is. So Postman, this is a tool. There's a couple tools like this. You do need to create an account. I'm just going to sign in with Google. Learn. Oh, come on now. There we go. All right, so once you get it installed, you may get this page right away. You might get more of like a welcome page, but this is the Postman interface. There's a couple tools like this on the web, but what they're used for is to test APIs and test servers. So instead of having to build an application to go get the data, we can just open up this tool, put a URL in here, and send a GET request to see what it sends back. So we get to see and play with servers before we actually have to write the code that interacts with them. And this is mostly used for two things. Before we're making our own server, this is going to be used to see what the data looks like the server is sending us. We'd like to see what our JSON looks like before we have to go deal with it. But later, once we're building our own server and APIs, we'll also use this to test our own. to make sure our server is doing what we programmed it to do. So Postman, it's a great thing. It's going to delete. That'll do. Okay. Is anyone still installing? Okay, we'll wait another minute until we get this all done. Hypertext transfer protocols, IP address, CRUD. If we need to get some of these other terms down, if we don't have it yet, client is the front end, also known as the device or the browser the user is using. So if the front end is the client, what is left? What is the back end? The server, and what else? The API, and what else? The database. So this is your back end. This is the whole front end. So this is our first foray in talking to that. So back end is the server, API, and database. Have you ever seen those videos? Maybe not. You might see it soon though, where it's showing, you know those shows that do really long shots? They're like 3 minutes long. It's one continuous stream. Have you ever seen the actual recording of one of those where you see the video and it's all elegant, the show, but in the background there's like stage people running everywhere, throwing props around, changing the time of day? That's how you kind of want to think of front end and back end. Front end looks nice. It's really pretty for the user and they get to interact with it, click buttons. But the back end is just going wild, trying to find, well, not trying to, but finding the data, sending it back rapidly, maybe doing some quick calculations. There's a lot of logic that we can shove back here. So the front end is just nice and pretty and quick for the user. If I can find that video, I'll show you just to give you a better idea what I mean. But things that you'll want to ingrain and eventually memorize from what we covered so far. What does HTTP stand for? And what are the CRUD? What is CRUD? When someone says, tell me what CRUD means, say, well, those are the 4 main rules of HTTP, and they govern how to get data, add data, delete data, and update data. Their methods are get, post, put, and delete. So we're going to start off with a GET request. Does everyone have Postman now? Yeah, I don't worry about any of that. We just need the basics for the time being. Now all we need is a server to request data from. Unfortunately, you can't just say, do a GET request to google.com and send it and hope we get back all the data for Google. What we actually got back was Google's website. We got Google's homepage. This is not JSON, this is XML. It's showing you that that's what Google is using. So simply requesting from a website isn't how you use HTTP. Their server will have specific areas that listen for user requests and send back very specific responses. So just to give an example, I'm going to go open up swappy.co. It's short for Star Wars API. This is an online server free to use that provides all things Star Wars related. You can make a request and get all your favorite Star Wars things. We'll interact with a lot of APIs throughout the course, but let's look at this for a second. We'll come down and it says try it now. And it gives us this URL and then a specific way to end it. So we can say, okay, let's test that request. And then what are we seeing here? Is it really an object? It's JSON. So I say, hey, Star Wars API, I would like the first person in your database. That's how they organize their API. Their first person in the database happens to be Luke Skywalker and everything about Luke Skywalker. One giant object for Luke. Well, let's change this endpoint. I've used this before, so I know. But instead of saying I want the first person, I'm going to ask for all the persons and request. Now what did I get back? I got 87 of something. So I look at results, and it's an array of objects. Where the first one's Luke. If I scroll down, that object ends, and another one starts with the same keys, but now it's C3PO. And then R2D2. So this is a perfect example of what APIs will look like now that we start using them. We'll send a request, a GET request, something like this. I need to get all the people from your database. We'll request it. It'll send this back for us. It's a lot of data to deal with. So I'm going to test this inside of Postman and see if it works. And feel free to fill this out with me if you have Postman open so you can see it on your screen as well. But make sure up here in the top left, we can choose which HTTP rule we want to follow. Notice there are more than the 4 that I told you about. That's okay. We don't need those other ones right now. The only one you may run into eventually is patch, but the rest of these, half of them I don't even know what they do. I've never seen them before. Get though, get's very important. So I'm going to put in the endpoint that it gave me here. HTTPS swappy.co. So https://swappy.co/API/people/1. So I've got that entered in. And I have this sitting on GET request. So if you write this in, you change this to GET, go ahead and hit send. I sent my request, and what I got back was an HTTP response of my JSON. Showing you, I don't know what the data looks like until I go test it. This is one of the first reasons we'll be using Postman. Any questions up to here? I know I've kind of been talking, so I covered this. Trying to get this visual idea of what's happening. And we covered the CRUD routes, or the CRUD methods. Good? Clicking so far? At least high level? If not, that's fine, we'll see it. Well, here's the thing. Most APIs won't want you to change their database. It's not yours, it's theirs. So while we can get this data, what do you think our ability is as far as being able to add, delete, or update? 0. They don't give us the ability to do that. Most APIs won't, because then you could just wreak havoc and mayhem and all that. So what we have done, well, when I say we, I mean Bob. Bob made a vSchool API that we can use to do all 4 requests and kind of practice these methods. So we'll be coming back to other APIs, but let's look at the one that Bob made. And so we can practice these 4 method types. So on a coursework site, you say vSchool API. Now we're trying to find the documentation for this specific API. Each one you'll have to request it differently, and then we'll take the information and put it in Postman to get the data. So right now, okay, here we are. vSchool's to do API documentation. I'll put a link of this into Slack right now, just so you know it exists. Because every API should have documentation. If it doesn't, don't use that API, because you won't know how to use it. Anyone that has tried that before will attest. It's a horrible thing. You want to be able to read how to use their API, much like you would how to use readline sync. So here's the first foray into reading documentation for an API. The first thing he says, the base URL is this. The base URL is saying all requests must use this format. You'll change some things about it, but this is the basis of what you have. Then you'll see symbols like this inside of some documentation. And that just means this is a placeholder word where I need you to put actual data. So where it says api.bschool.io/your name, you would delete all that and literally put your name in there. Not literally the word your name, but you get it, okay. / you do / and then we could put an ID at the end if we wanted to. Oh yeah, and there's a little example of it. And then here is documentation on how to do the for request using this API, how the URL needs to be constructed. So this API is pretty cool because if you put your name in here, you'll have a different database than someone else using the same API. So as long as you're using your name and not someone else's, you'll have your own list you're dealing with, and it's permanent. All this is getting saved in the database as you're adding and saving and removing data. So I'm going to paste this URL into Slack because I would like everyone to, along with me, take it into Postman. So I just put this in Slack. Go ahead, open up Postman, and where you have the get request line here, replace it with the URL. I wish I remembered how to zoom. Now where it says bracket your name bracket, delete that and put your name in there. So I'm going to say mine's going to be Nate J. Just be aware there's probably multiples of your names that have come through this course. So if you don't use an initial or something, you might be getting someone's old database. So that'll be fun to see here in a minute. Once you have your name in place of where that is, go ahead and hit send on a GET request. And you shouldn't get this. You should get an empty array. This is my, apparently I used this one before. I'm gonna change it a bit. Okay, you should get this, empty array. Everyone get that? This is a successful server request. We went and asked the database for all the to-dos underneath your name. You haven't made any yet, so it sent you back an empty box. Oh boy, no, those will, that's the nature of it, yeah. But as you'll notice, if I use one that I used in a previous cohort, if I do a GET request, here's all the to-dos I added via post requests. So later on today, you'll be able to do a GET request and see things you've added. So we're going to do a post request, we're going to do some more GET requests, and we're going to call that good for the time being as far as practicing this. Because that's a good amount right there. Let's look at post. What does a post request do again? Adds new data to a database. So where your array of to-do objects are empty, you would like to add an object to this. Add some new data. Well, to do this, I need to go look at the documentation to make sure I'm sending it the way it expects. So it looks like the endpoint or the URL for GET and POST are the same, so that's fortunate. I don't need to change anything there. Ooh, but look at this. The database model looks like this. Interesting. So this is way down the road when we start writing these ourselves, but what this is a blueprint of when you add an object to this database, this is what the database is expecting. If you send an object with a key, instead of it saying completed, it says done, the database will reject it because it's expecting the word completed to be a property of that object. And this is nice. We want our database to enforce consistency. We don't want objects with different key names because how can you loop over that and use it dynamically? You can't. They all have to have a title and a description consistently. Now, just reading this, the only thing this API actually needs is a title, as denoted here. It's required. We have the option to send a description and a price and an image and a completed. And then if you read the note up here, you won't need to mess with the session ID. That is handled automatically. So this is just for your info, but the database does that for you. So whenever you use this API, these are the 5 things you can send, and only these things. So let's do it. Let's make an object and add it to the database. Okay. First steps first. What kind of request are we making again? Post. So I got to change my selector up here to post from get. Tell I'm making a post request. We saw that the URL stays the same, so I don't need to touch that. But now I need to send the server some information. I need to send it the item to add. So the way we do that, and you'll want to watch on this because the first few times it's easy to get lost. At the top here, we see params, authorization, headers, body, something else. We need body. The body of a request is any data the user is sending you to be like added to a database. And we want to send raw, and we change text to JSON. So we click body, we change it to raw, and then we change a little slider over here from text to JSON. We got that. We'll take a second maybe to find this. If you're seeing body, cookies, headers, test results, that's the wrong body. That's the response body. We're working on the request body. Yeah, there's a couple of them. Once we're in here, we're writing JSON. This is our JSON where we get to send our new JSON objects to be added to the database. So we know our to-do needs a title, so we'll add that. We only want to send once we're ready to add this to the database. If you click send without a body, it won't do anything, fortunately, because it won't have anything to add. But what I'm doing right here is I'm filling out a request body. I'm saying this is the object I want to add to the database. This object has a .title. I'll say my very first to-do. And then what other options could I give this object? What other properties? Description. How do you know description? Because the database, this API is allowing for this to be added in each object. So we can send a title. That's required. We have to send that. Then optionally, we can send a description, a price, an image URL, and a completed Boolean. So we're going to add them all for the sake of practice. So the next will be description. Oh, I hope this works. And make sure there are no typos in your keys because the database won't accept it. Next, I'll give it a price. This can just be a number, 200 bucks, or 200. The next one is image URL camel case. So for that, I'd need to go grab an image URL somewhere. I'll come to Unsplash and just copy image address, paste that there. One moment, don't do that. That's not me doing it. And then lastly, we saw we could add a completed. It has to be Boolean, so this will be completed. By default, it probably is not completed. So if you read the notes here, you do not need to mess with the session ID. This is handled automatically by the database. Doesn't say that, but that's what's happening. There's actually a few other things the database will give us as well, which we'll see in just a minute when we post this. So once you have at least the title written in, or all of them if you wish, but at least the title, go ahead and hit send. And then scroll down the page to where it looks like the object is there again, but it has some things added to it. What's been added to this object that we didn't give it? ID. Yes, all the errors. But yeah, quickly here though, or not quickly, but notice what has been added, and we'll make sure everyone gets a successful one out. I sent it title, description, price, image, and completed. It sent all those back with an added ID, session ID, and a version. These are all given to you by the database. You don't need to add them. And in fact, we won't even use any of them except the ID. The IDs will be extremely important. That's the only way to differentiate items in a database, because otherwise they all look the same. But every item will get their own unique identifier. So in case I ever wanted to just get this one item from my database, I have a way to request it by its ID. Kind of like how we get elements by their ID. Okay, so who hasn't got one successfully posted? Make sure that works. Go. Hey, just for the sake of practice, once you get one added, wipe it out and just make a new one or change like one key in here. So I'm going to change this title to now, this is my second to do. And I'm going to hit send again and scroll down to see the response came back with my object with some more data added to it. So all I did was change this text in the title and I sent another request. Once you've added these, go ahead and change post back to get, click send, and tell me what you see down below. Do you see both of your to-dos in an array of objects, an array of JSON objects? The nice thing is when you turn off your computer and come back in tomorrow and you do this get request, they'll still be there. These are all in a database, it's permanent. We now have data persistence. Your website doesn't wipe itself out when you refresh because your data exists somewhere permanently, as long as you're grabbing it. Was everyone able to get an array back? Even if you only added one object, you should have still gotten an array back with one object in it. I just added two, so I got two back. So it'll take a little time and practice to orient yourself in Postman, but just high level here. There are two windows in Postman. There's this top window, and then there's this bottom window. This is the request response cycle. The top window is the request. This is where you can type in information. The bottom window is what the server sends back to you. Now, it's pretty often that people will come up that says, hey, I clicked on body and I'm trying to type in here and it won't let me, because this is the response window. We cannot type in the response that's given to us. We can type in the request window and use this request body so that we can receive a response body. We can look at it as a raw string, we can preview it as text, or we can just see it prettified as JSON. Yes? Are we feeling the after lunch wave right now, compounded with the wave of Fridays? Yes, that's where I'm getting the vibe right now. But I know this is kind of a quick, or not quick overview, but high level. Is there any questions with Postman? What is Postman for? Why are we using it? What are we doing? Saving JSON. Where does the JSON get saved? We send it to a server. We're making a post request to vSchool server, and then vSchool server is doing some magic to add it to a database, sends it back to the server that then sends it back to us as JSON, and we see it pop up in Postman. So post request, saved in database, comes back as JSON, gets to us. Have a question? Oh, I had a question. Okay. Okay, so the next part of this that we're going to do is actually implement this in JavaScript code and actually get data in a JavaScript file from the web. But that's going to take a little time, so let's take a little break first.